Let's take a look at this circuit here, and in this circuit we have two meshes. This mesh and this mesh that's already defined, and we're told to find the branch currents I1, I2, and I3. We want to figure out what I1 is, I2, and I3 are. So we define these mesh currents within these two meshes, little I1 and little I2. So that's the first thing we want to do. So they're given. So first thing is define mesh, meaning our mesh currents. Okay, and this is given. They're giving it to us. And the next thing we want to do is we want to apply KVL, Kirchhoff's voltage law. So let's start with mesh 1. Mesh 1. And then go around that. Okay, so if we look at mesh 1, we have minus 15, whatever this voltage across this resistor is, times the mesh current. So now we're going to look at the V equals IR. So little I1 times 5. You come down here, this resistor, 10 ohm resistor, is sharing two mesh currents, I1 and I2. So we're going to have to subtract those guys. Okay. And then as we go down, there's a voltage source here, plus 10. And you just go back around in a circle there. So let's go ahead and write that down. So mesh 1 is going to be minus 15 plus V equals IR, which is going to be 5 ohms times I1 plus 10 ohms times, this is going to be I1 minus I2, because what's happening here is we have I1 coming down this way and I2 going up this way. Okay, 10 I1 minus I2 plus 10. We set that equal to 0. We can solve that, simplify this a little bit more. Say 3I1 minus 2I2 equals 1. So we have one equation here that we can utilize. Next step is we look at mesh 2. Okay, same thing, we're going to apply Kirchhoff's voltage law across mesh 2, so we're just going to go around in a circle. Okay, so we can start at minus 10 if you wanted to. Let's go ahead and say minus 10, and then we get the 10 ohms, and this time it's going to be I2 minus I1, because I2 is going in, I1 is coming out. 6 times I2, 4 times I2. Okay, so let's go ahead and write that down. For mesh number 2, we got minus 10 plus 10 times I2 minus I1 plus 6 I2 plus 4 I2 equals 0. We can simplify this. We get I1 equals 2I2 minus 1. So this is our second equation that we're going to utilize. Okay. Now all we have to do is substitute back in, and then we can solve for the currents, the big I1, I2. So let's do this. So we have these two equations, and then I didn't put it in the same format, so technically I could put this in the same format So I can say, let me rewrite this. Let me rewrite this guy. So we got I1 minus 2I2 equals minus 1. Okay, so that's another way of writing it. Alright, so we have these two equations. So there are two methods to solve these equations. Let's do the traditional way. So let's look at method 1. Method 1, and that's just the traditional solving the equations. I can substitute these equations into each other, and I have 6I2 minus 3 minus 2I2 equals 1. This will give me I2 equals 1 amp. Okay, next we can substitute that in to the other, that I1 equals 2I2 minus 1, but we just said I2 is 1 amp, so it's 2 minus 1. That's also going to give us 1 amp. Okay, so now we got I1 is equal to 1 amp. So what's left is we need to figure out the capital I1, capital I2, and then we know that from just looking at the circuit that I1, capital I1, is equal to little I1, which is going to be 1 amp. Capital I2 is equal to little I2, which is equal to 1 amp. And I3 is equal to I1 minus I2. And that's going to equal 0 because we're going to substitute those in there. So if we look at the current here, we go back here. I1 is just, capital I1 is just going to be little I1. Capital I2 is just going to be little I2. And I3 is going to be I1 minus I2. Little I1 minus little I2. And that's how we get those numbers. And then this is going to be our final solution in this problem. Okay, this is one method of doing it. The other method is to use Cramer's rule. Okay, so method number 2 use Cramer's rule. And essentially what we need to do is take the coefficients, 3 minus 2, so we take coefficients 3 minus 2, (1 minus 2). or minus 1 and 2. Okay, so I1 minus 2 minus 1. Okay, so let's put those in here. 3 minus 2 minus 1 and 2. I1 I2 equals 1 1. Okay, now note I changed the signs here. I made this a minus, I made this a plus, and I made this a plus. That's why these signs are this way. Okay, I could have done it the other way, kept it originally. Okay, but essentially we can utilize this method, Kramer's rule, and then Kramer's rule utilizes determinants from linear algebra. So you can say our determinants is going to be defined by a triangle. So the determinant is going to equal to 3 minus 1 minus 2, 2. So that's going to be 6 minus this guy. So you cross them like that. So we got 6 minus 2. Minus 2 times minus 1 is 2. So 6 minus 2 equals 4. And then we look at determinant 1 is equal to, this is Kramer's rule, by definition of Kramer's rule is going to be 1, 1 minus 2, 2. We take that, that's going to be 2 plus 2 equals 4. And then the second one is going to be 3 minus 1, 1, 1. We cross them, 3 plus 1 equals 4. Thus, we can go down here and we can say, again, by definition, I1 is equal to this guy here, which is going to be 1 amp, and I2 is this guy here, which is also 1 amp, and then we can solve for the rest of it as before to get the capital I's. So two methods to solve the same thing for this circuit here. Method 1 is the traditional, just solving the algebraic equation, and then method 2 is utilizing Kramer's rule.